Good morning, Year 8. Welcome back to our lessons. A slightly different format today, just because I've got something particular I want to cover with people. So it's not a PowerPoint today, but one of my sets of slides. So again, thank you for engaging with these online lessons. As always, if you could please click a little submission of your work on Show My Homework so we can see who's accessed the lesson. And then today's lesson is going to be self-assessed, and then you might need to pause the video right near the end so you can get the answers to self-mark with. And again, if you need any help, please get in touch with me at red@theroyal.school. And if you can save that just for help messages and then submit work via Show My Homework, that'd be fantastic. So today we're going to have a look at calculating compound areas, and these are areas related to several shapes of the basic versions that we saw in our previous lesson. So for our starter activity, I've got us having a look at 4 shapes up on the board here. So I'd like you to try and work out the area of these 4 shapes, please. Let me just remove the browser from the side so you can have a better look at those. So if you can calculate the 4 areas, please, and you may wish to pause the video until you're done so we can then run through the answers. So first rectangle here, we should have had 9 times 4 to get our area, so we get an area of 36 centimetres squared. For the blue square here, we should be doing 6 times 6 to get 36 centimetres squared as well. For our parallelogram here, then we should be doing base times height, so we only need to do the 7 times the 5 to give us 35 centimetres squared. We don't need the 6 at all, the diagonal line there, so there's no need to be using that one. It's not related to our area of a parallelogram. And likewise with our triangle, we need to be doing half base times height. So the base is 8 and the height is also 8. So we need to do half of 8 times 8. Well, 8 times 8 is 64. So half of that is 32 centimetres squared. Again, you don't need this diagonal line of 9 centimetres. It's base and height that have to be at right angles to each other that you need for the area of a triangle. So if you need any more help with those, then let me know so I can give you some support work on those basic shapes, because otherwise we're going to be using some of those later on in the lesson. However, there is one final shape that we need to have a look at the area of. It's quite a complicated one, so you may wish to write down one version of how to get the area of this shape. So we're having a look at area of a trapezium. Now the area of a trapezium is given in a worded form that I've got in the red box here, and you can also have it in a formula way of writing it with letters, which helps you by using the diagram just above it. Let's have a look at the 2 methods we've got though. So a trapezium is a quadrilateral, a 4-sided shape, and its properties are that it has 2 parallel lines. Now in this case, the parallel lines are, if I highlight them in red, the top and the bottom. They don't always have to be the top and the bottom, they could be on the sides, but in this case the parallel lines are this line A and this line B. And parallel lines, as we know, run in the same direction. They don't get closer or further apart from each other. So A and B are our parallel lines. And we also need the height of the trapezium, and the height of the trapezium is always the distance between those parallel lines at right angles to it. So you can see H, the height here. Now, if you're using the formula, then we're going to do a half of brackets A plus B, so that's our parallel sides added together, and then there's a H at the end. And as we know that when we're writing things in algebraic formula wise, there's like a hidden times sign between those. So a half times the sum of those parallel sides times by the height. Now you may wish to write down the worded version in the box instead, where you add the parallel sides, you halve your answer, and then you times by the distance between them. So let's have a look at how this works out when we've got these parallelograms, not, they've got trapeziums underneath. So we've got a blue trapezium here, where I've got the identify the parallel sides first. So our parallel sides are going to be the 6 centimetres and the 14. And therefore the height then is going to be our 5. So if you were using the formula, you could replace 6 with the A and 14 with the B, wouldn't matter if you did that the other way around, but 5 centimetres definitely has to be the height. And if you're using the worded version of this, we're going to add our parallel sides. So we're going to do 6 add 14. We're going to half our answer, and then we're going to times by the distance between them, so times by 5. So we should end up with half of 6 plus 14 times by 5. Now think back to your bid mass here. We're going to need to do the brackets first. The 6 plus 14. That gets us 20. We're then going to need to either times by 5 or half. They're all multiplications there, so it doesn't really matter on the order of the set of multiplications, but a half times 20 times 5 is going to give us 50 centimetres squared overall. And then we do the same with the purple trapezium. So which are our parallel sides? In this case, they are the ones that are vertical. So we've got our 24 and our 8. And the height, it's a bit strange to call it height when it's across the bottom of the shape, but our height is always at right angles to those parallel lines. So if our parallel lines are the 24 and 8, our height has to be the 5. So here we'd be adding our parallel sides, half the answer, and then times by the height between. So that's going to give us a half of 8 plus 24 times by 5. And again, bid mass, so do your brackets first, and then half, and then times by 5. And that's going to give us 80 centimetres squared. So there are going to be a few of these for you to try now. So I'll leave these up on the video. So there are 16 of those. Let's make that a little bit bigger. So 16 of these for you to try. I would give yourselves about 8 minutes to work through those. You can see there's definitely some decimal numbers when you start to hit question 5 onwards, so calculator use is absolutely fine for these. So give yourself about 8 minutes on these, pause the video until you've had that time to work through as many as you can, and then we can run through some of the answers. Okay, on to answers then. So if you can self-mark your own work on this, that would be fantastic. And then we can move on to our next part of our work. Okay, so if you can self-mark your own work, and when you are ready, then we can move on with the video. So pause until you've had a go at marking those. So on to the main part of the lesson, which is our compound areas. So a compound shape is one that is made up of several basic shapes that we should already know how to work out the area of. So in this case, I've got this L shape on the board. Now, you should be able to spot that this L shape could be made up by 2 rectangles. Now, how you split the shape up into 2 rectangles is entirely up to you. So we could split it up with a line straight downwards. We've got 2 rectangles there. So if you wanted the area of this shape, work out the area of those 2 rectangles separately and add them together at the end to get your final area. We could have also split it up this way, which is going to give us exactly the same answer, but we worked out in a slightly different way when we did our calculations. It doesn't matter which way you would go about that. What I wouldn't do though is want to split things up into 3 rectangles. It again would get you exactly the same answer. However, what you don't want to do is make more work for yourself than necessary. So 2 should be sufficient. So I'm going to split my shape up vertically here with this line straight downwards, where we've got the split of our shapes. And then we've got our 2 rectangles to work out. Now the first one to calculate should be nice and straightforward. We've got the rectangle here, and then it's got a height of 10 and a width of 3. So that's great. So all we need to do is add 10 times 3. So we're going to have that area of that rectangle as 30 centimetres squared. For our other rectangle though, we need to be careful because we don't have all of the measurements. The second rectangle going across here is definitely 4 centimetres high, so that's fine, but it's not 12 centimetres across because that's the whole shape, and this little rectangle here doesn't take up the whole shape. So what we've got to imagine is, well, if the whole shape is 12, but this part we were using for the other rectangle was 3, then the line at the top here, or the bottom of this rectangle, has to be the 12 take away 3. Excuse my mouse handwriting there. So 12 take away 3 is going to give us 9 centimetres. And therefore this smaller rectangle at the right hand side is going to be 4 times 9 to give us its area. So we have 36 centimetres squared for the area of the one on the right. It's really useful if you've got diagrams to sort of show how you've split them up, show the two separate calculations so we can check any answers later on. And then of course, to get our total area for this shape, we're going to need to add those areas together. So we need our 30 plus 36, and we get our final answer there of the 66 centimetres squared for this shape. So we might also have another problem based on rectangles here. So here I've got a diagram showing a wall with a door in it, and we want to work out the shaded area. This works in much the same way here, although what we might recognise in this case is we've got a big area of the large rectangle that makes up the outside of this wall, but we're actually missing this area in the middle. So rather than adding our areas together in this case, we actually need to subtract them. So in this case, I'd work out the large area of the whole rectangle, which would be our 4 times 3. So this area is going to be 4 times 3, which is 12, not centimetres, be careful of units, 12 metres squared. And we've also got the area of the door, and this is going to be a rectangle that's 2 times 1, so that's 2 metres squared. But in this case, as we said, the door isn't part of the wall, so we need to actually remove the door's area from the wall's area, so we actually need to do 12 minus the 2. So here we get our 10 metres squared for our answer for this. So you see we've got a 3 mark question here. So we can have a mark for our area of the wall, a mark for our area of the door, and a mark for doing the subtraction here, and obviously getting our right answer from that. So we don't just have to have rectangles as our shapes when we're looking at compound ones either. At the higher end we can see we've got maybe this house shape here, and we need to look at how we could split this one up. Let's have a think about that for a moment. So hopefully we could split this one up into a rectangle and a triangle. It would have been fully plausible to split this one up into 2 trapezium shapes if you split it up down the middle like so, although I don't think that would be probably the easiest way of splitting the shapes up. 2 trapeziums is going to be a little bit more difficult to work out than a rectangle and a triangle, although it's up to you. It should still give the same answer. So I'm going to split this up horizontally across here, so we get the rectangle and the trapezium. Rectangle and a triangle, sorry. So we need to work out that missing height there, and again, if the entire shape was 10 centimetres tall and this part of the rectangle was 6 centimetres tall, then that means that the remaining height of the triangle had to be 4, so that our 4 plus our 6 still equals the same height as the entire shape, the 10 on the right hand side. Now we can go and work out our areas of each of these shapes. So the triangle, if the base of the rectangle here is 8, the base of the triangle is also 8. There's a property of a rectangle there. So half of 8 times 4 gives us 16 centimetres squared for the triangle. And then our rectangle, nice and straightforward, 6 times 8 gives us 48 for the area of that. And therefore add those together, and we get 64 centimetres squared for our total area in this case. So our compound area has been calculated. So there's one that you might want to try here just before we get into some main questions, or if you're still a little unsure, then listen up and we can run through this example again. And if you'd like to have a go yourself, pause now just before I start to work through this one. So working out the area again, we're going to split this shape up into easier ones that we know. So I'm probably going to go and split this one up, going acrosswards here. So we've got a rectangle and a triangle again. Now, the rectangle area is going to be nice and straightforward. We've got our 12 centimetres here and our 5 centimetres here. So we need to do 12 times 5, which is 60. The triangle, though, we actually don't know the base of it and we don't know the height of it anymore. So what we did know was that the entire shape going acrosswards was 12, and then this part of the shape going across is 7. So what we actually need to know is 12 take away 7 to get the width of the triangle at the bottom. So 12 take away 7 is 5. So it's going to be 5 centimeters for the red line for the bottom of the triangle. Now the height of the triangle we also need to work out. Here we've got the entire shape was 9 centimeters tall, but we know that this line going upwards was 5, so we need 9 take away 5, which is going to give us 4 centimeters for the height of the triangle. So the area of the triangle, pardon me, we're going to need to do a half times 4 times 5, and a half base times height for a triangle. 4 times 5, I know it gives me 20, so half of that gives me 10. Excuse the mouse handwriting again. And then add those areas together. So I'm going to need the 10 centimeters squared for the triangle, plus the 60 centimeters squared for the rectangle. That's giving me a total of 70 centimeters squared for the total area of this shape. So that's that compound area questions. So I've got 12 of these that I'd like you to have a go at. It'd be well worth drawing a little sketch of these diagrams for you. You can see we've got some grey lines here as well to give us some of the measurements here. So we know that this line here is the 4 millimeters. So there's 12 of those for you to have a go at. I've also attached an extension sheet to show my homework for those that need to make up a little bit more time on these exercises if you're getting through them very quickly. If you're feeling quite confident, you might want to start straight away on the extension sheet for this one rather than the ones on the board, but there's a couple of options there for you. So for the remainder of the lesson time, if you can work through these questions that are on the board, and then when you're ready to go through the answers, then they're going to be shown in just a moment. So pause until you're ready for those. Okay, on to answers. So here are the answers for the questions that were on the video just. And again, if you're working on the extension sheet, I can show those in a moment. So again, if you need these answers, pause. And onto the extension answers. Once again, if you've not yet sent me a little message on Show My Homework to show that you're engaging in this lesson, then please do so that I can mark you down and give some reward points out. And if there are any problems, please get in touch with me at red@theroyal.school. Thank you very much once again for listening. Hope you have a fantastic day.